Thank you, everyone, for joining the Schmidt Ocean Institute live stream, dive stream of the ROV Sebastian. We are in northern Patagonia, and my name is Becky Totten. I'm from the University of Alabama. Sitting next to me are two very capable ROV pilots, Scott and Zach. And Sophia is working the live stream for us today and making sure everybody stays on track. We are diving to the bottom of the seafloor, and we are located in this region of northern Patagonia, looking at the influence of volcanoes on marine basins, how volcanic sourced sediments get deposited within these marine systems, and how they affect the life in the water and on the seafloor. And so we are located just offshore of the Rayas Delta, and we're looking for influences of the recent 2008 Chai-10 eruption that caused massive destruction of the city there, and took a long time for the city to recover and move back into those areas. And so we want to look for the event bed, the tephra layers that were produced by that massive eruption that got remobilized after rainy events and transported through the river systems out into these basins. So we've just landed on the seafloor here, and we are taking water samples first and foremost. Yeah, it looks very different. This is, I don't see as many pebbles. Looks much sandier. Oh wait, did we get our Niskin? Yeah, you're good to go, Niskin. A Niskin is a water bottle, essentially a fancy water bottle. It stays open as we dive to the seafloor. It's on the side of the ROV. You cannot see it through the screen here. But it's on the side, and all we have to do is punch these little triggers here, label 1, 2, 3, 4, 5, 6. Okay, so we're going to fire the Niskin. So we close it up and we capture the seawater right here on the seafloor. So the first step, once we get down here, we'll look at this water later for things called stable isotopes, and the elements within the water itself that might have some metals in it that tell us about the influence. Yeah. So we're getting the water samples. We're going to take them back to the laboratories at our respective institutions and look at the composition of the water. At the same time, we're taking samples of the seabed, and it looks very different here. With me is Dr. Seb Watt from University of Birmingham. He's been working many years to make this a reality where we can actually sample the seabed with an ROV. We're very lucky to get to work with SOI on this project. It's the first cruise in which we're able to take vibrocores of the seabed. And that's the main apparatus that you see there, kind of blocking the camera view of the arm, the sort of black metal part there. All right, so things that we're noting on the seafloor is that it's much finer sand than before. We can see finer ripples. I think it would be great to try a core here.
Yeah, I think we should do a scoop first, Becky, just to think if we're seeing any evidence these pebbles.
We just got one scoop.
Oh, we done the scoop
Yeah,
already?
we did the scoop already. We multitasked a bit
Sorry,
here.
I think I signed out of the room.
So we just took a scoop of the seafloor, and now we're debating, should we try the vibrocore again?
So no evidence of ripples here.
I think no, there's ripples, but they're much finer scale,
No.
and you can see they're kind of highlighted with the lighter colored particles.
The ripples are not stratified. Ripples are moving a strong single direction here.
Yeah.
You see quite,
So this might,
yeah.
rather than an area where it's transporting.
Pale-colored sediment.
Yeah.
This is going to be vibrocores, not quicksand,
Can I
right?
use that? The other thing that I'm noting here, and maybe we can make this. I want a vibrocore.
Yeah, okay, go for it.
We're going to try a vibrocore here. The other thing that seems really interesting is I see some woody debris in the upper left part of our screen. And I think that that's a clear indication of the river input to this basin. So yes,
Could be, yeah, that's very interesting.
I would like to get a nice core. Oh gosh, yep, those white grains there, those look just like the pumice clasts or pieces of pumice that would be derived from Chaitin, from the major volcano that we're interested in studying. All right, let's go for a vibrocore. See how it goes.
Try the one without the valve.
You want to do that one first?
Stand by, Zach.
What do you think?
Let's do. Okay, yeah, let's just do this one first.
We could always do it too.
We could do two.
Let's see how it goes. Right.
Going for it.
And part of the reason you hear us working pretty quickly here is that we've been fighting with the currents in this region. So there's pretty fast currents. We cannot operate the ROV when the currents are too high, too fast. And so we're trying to get as many samples as we can during this window in which the currents have died down a little bit before we need to bring it back up to the ship. Right now we're in about 130 meters water depth, and you can see we're attaching the vibrocore tube to the apparatus here.
Which is good because that means it does take. So there's a lot more than in other sites.
Yeah, there's woody debris.
Yeah.
This river input. This is like deltaic. I'm convinced.
Yeah.
I mean, yeah, the subaerial delta is
Yeah.
covered in tree trunks.
Yes, exactly. You can see them in the satellite images. Yeah, so we're just talking about how the area around Chaitin, even, the area around the city of Chaitin, there's a lot of trees that were basically just uprooted and transported by the rivers following the volcanic eruption. And you can see them even in satellite images. So if you want to play with a Google map, you could see those tree trunks just sitting on the surface there. It's a great indication that this is river sourced sediment here, that we have these plant debris on the seafloor. Okay, so the vibrocore's gone in about halfway. Is that right? So we've pushed it in. How much resistance are we getting, guys?
Not much.
That's a great indication.
The problem with the core cut. Because we get too many pebbles in there and it never really closes well.
Oh.
So we move up, it's still kind of open and we start losing material. And this is sand, it's not stick to anything. So
That's
it's
a
Yeah.
just
possibility.
Sand
We
should-
just leave it down again.
Yes.
Yeah, that's possible.
Okay.
Because it can't close.
So we're really happy that here we don't have as many pebbles getting in the way of our coring procedure.
well, it's just luck, because we will penetrate enough, and that's the thing. We don't know what's going to.
This
If
is
we get to a
actually-
finer material, so the
This is
actual
a good
core
reason to collect too, as well.
exactly.
Yeah.
So we might get lucky. So you will get to an end.
Wherever you're joining from, feel free to say hello in the chat. Tell us where you're joining from. We've had a very international crowd.
So Becky,
Okay.
the
Yeah.
scoop bag.
Yeah.
Did you go for the blacker sand, or did you get a good amount of that?
It was pretty mixed.
So maybe could we
Yeah.
scoop where the organic debris is?
Right there. Yeah. Totally agree. Let's take scoop 2.
I think given how this is going in.
Hey, buddy.
We're getting messages again, Becky.
I know. I miss you. Yeah, so that's something we don't talk a lot about, but all of the crew and the science party, we have to be away from home for a bit of time to do this kind of work. And I think you really only do this work if you're, passionate about it and you feel real purpose in studying the ocean and studying how these things are changing. So we have to be away from our families. It's hard to do, but hopefully we will learn a lot from this expedition. All right, so it seems like we might have a full barrel here if all goes to plan. Full core tube. How much resistance did you get on the second part of the drive?
Just before we had to wiggle.
Had to wiggle, okay.
Can we vibrate in the way? So it has to be.
How much was it? Like the whole 2 meters?
It was the full tube, yeah. I think this is 1.5 meters. Well, yeah, it's 1.5 meters tube.
Okay.
Okay.
Yeah.
I think it would be better to just vibrate. The moment before we decide, okay, what we're gonna have to see if the thinkers can actually move and maybe have the chance to close. I will do like and then move a little bit up and see if that will help. In theory, right? If something is stuck in the wood, maybe we can get off and we give a chance for the fingers to do this, and we go like full vibration.
To get them to close.
Yes.
Okay.
Before
Even
pull.
if some falls out, that's what we want.
Yeah, that's fine because right
Yeah.
now we're losing maybe this much. Right?
Yeah.
So maybe just before we start pulling up, go full vibration, and maybe the first try clean up for just a few seconds, keep vibrating. So maybe.
Okay, but here's my point. If it's full, right? We're only transferring it from this part of the ROV to that holder. If we don't see anything fall out and we put it in the holder.
I think we might be losing material
When
in
you
the same
lift it,
hole.
literally
Yes.
when you lift it up.
Literally,
Uh,
The
yes.
core can't close.
Yes.
Because it's being pushed
I
back.
know, but we're not seeing it on the feed.
No, we
So
can't.
is it happening as
Because
we're
within
flying
the
back
hole,
up to the
yeah.
ship?
No, it's in the ground.
In the ground.
Oh yeah, I see what you're.
Can
Okay.
Still not.
Right.
So shake it a little bit
Yes,
more
yes,
before
yes.
pulling it out.
Not a
Okay.
little bit, I will shake it the hell out of it. I'm sorry. I will
My
shake
kids?
it a lot.
You're listening.
This is for all the kids out there. Don't say that word I just said.
Who you're hearing right now is Dr. Rodrigo Fernandez giving us an example of how to not use certain terms.
But
Rodrigo is my longtime friend, one of my very best friends in the world from the University of Santiago, but we did our...
University of Chile, Becky.
Oh,
Please.
sorry, University of Chile in
That's a different
Santiago.
University. And she's saying it's my friend, he doesn't know where I work.
I know where you work. I'm just trying to talk very quickly to get back to ops. But yeah, we did our PhDs together, and we probably know each other too well. So he's always giving me a hard time. I think that's the best part of this science is the people that you meet, and it's like a family all on its own. So yeah, very, very, very lucky to have good friends and colleagues
Hey, Mom.
working together on this ship.
Did you see the chat?
Yeah, I saw.
Ready?
Okay, so we pulled out the vibrocore, and we're hopeful that it's full of sediment right now, and that core catcher that's riveted to the bottom, I don't know if you guys can see the little dots on the bottom of the core there, that it's held that, those metal teeth have held the sediment within the core barrel. Oh, and we're seeing some cool biology there. Did you note that, guys? Did you see that? It's kind of, I don't know what it was.
One of those reds.
We'll have to mark it on the log and go back and look at the feed again.
So Becky, what Rodrigo was saying about testing vibration to get
Yeah.
the core catcher first, I think this would be the site.
This is the
test
site to do it,
So
because it
I
went
suggest
in.
We take a duplicate.
Do you want to do it with a valve or without, though?
I'm inclined to keep everything else the same.
Yes, don't introduce variables.
see
It's
which
exactly.
is-
Okay. So, Scott and Zach, are you good to do another vibrocore?
The stow this one, and then we'll move somewhere. Do a second.
Okay. Okay. Well, no, we're gonna do a second one in the same site.
Here?
The surface current is increasing
John,
a
it's
little
there
bit,
again.
not
See
increasing
it?
more yet, but is increased 0.3 the last 20 minutes.
Which depth has increased?
Yeah,
The surface.
he's just saying the surface.
On the
Oh, the
surface.
surface.
I've got
Okay.
eyes on it here.
Okay, roger that. Thank you.
And that would indicate though that this, switching to.
So we'll pick up and move over, but we'll stay at the same site.
Right.
I'm gonna try to keep all variables the same. And we'll just use the core number 2 as the valve on. All right, so we're putting the barrel back in the rack, and this is probably the most difficult part because it takes a lot of careful, deliberate motion on the part of the lead ROV pilot here. Zach is working hard to make sure it goes right where it's supposed to and lock it into place.
Really don't like these fingers, man. They just get stuck on everything.
Can you modify the fingers?
We gotta check them out. We don't need
We've been working.
Okay.
it. We don't need it.
Yeah, that was even flapping off.
Yeah, it doesn't help. It just gets stuck in.
So the ROV pilots can, and the whole team, the ROV team, can work on changing, modifying the ROV in real time, basically, as we
So they want to do
need it. So they have a 3D printer. They can change the shape of those fingers on the arm there. And that's what they're talking about now. Maybe change it back. Claps for the core.
Wait, what?
We should preload on deck first.
That one's gonna be, I don't know what to say.
Do you want to tell the audience?
No, it's alright. I'm with the computer and the
You
location.
sure?
Yeah,
Okay.
that's fine.
But it looks very similar to the fan delta.
Yeah,
Yeah.
just like I just thought so.
All right. All right. Okay, so we're going for a second core. And we're going to try a little different procedure, just try to modify a little bit here how we take it out of the seafloor to see if we get better recovery. And the reason we're taking these cores is we want to look far back in time. We want to look at sediment that was deposited not just recently, but in decades and even centuries before now, to see the eruption history in this area, especially of the Chai 10 volcano. Did you see that? It's a little bit offset there. To get back in, maybe we can use a different position on the core rack.
Yeah, we'll put in
Okay.
the second slot.
What's wrong? Why don't you think it'll be going the third one? Stop.
I'm sorry? What else? The collar on the thing loosened up as it's cocked.
Hey, Leo and Lawrence and Opie. Hey, Mom. So again, we're 130 meters
Punching down.
water depth. And we are
Oh yeah, that's right.
trying to punch into the seafloor with this cool device called a vibrocores.
You want to just kind of move.
Yeah, so just pick up and just move a little bit over, and actually, if you want to move closer to where that white material is, that'd be fine.
Okay.
We're gonna want to sample that. So we're just picking up and moving over a little bit to make a new hole in the seafloor.
Okay.
And now you can see even better. There's a lot of debris on the seafloor. A lot of it looks like sticks,
Sometimes I have to like.
plant remains that would come from the river that drains into this area. So we're right on the delta of that river, the offshore part, the underwater part that we normally don't get to see. But now we can with the ROV. It's really amazing. Okay, let's hope this goes in as easily as the last. Okay, so that device that you can see shaking there, that's the vibration of that is causing the core tube to also vibrate and vibrate the sediment around it so that it becomes looser so we can penetrate deeper. We can push that metal tube into the seafloor deeper than you normally would by just pushing it. So you vibrate it as we push it. How much resistance should you get there? Pretty easy?
Yeah, that one
Okay.
was easier. Well, so far.
Easier?
The first,
Okay.
20 centimeters. Okay. Clamping. Ready? On the vibration. You're pulling a Scott.
How far did the first one insert before they pulled it out?
It's like 1.5 meters. It was all the way
basically
up.
all the way.
It was all the way.
Basically all the way.
Yeah. It was just maybe like 30 meters, 30 centimeters.
If this also goes in all the way, then we can get a direct test of whether
Mhm.
this vibration makes a difference.
Yes.
We're getting some resistance.
Yes. Okay.
Yeah.
More resistance though in the second.
Okay, so
Part.
which means we maybe can't draw a conclusion. We'll see. Because if they go in different amounts.
Yeah, and all it takes is like a couple of pebbles to cause an issue.
It's really hard to experiment with.
Yeah, yeah, because that's just the nature of geology. You can have a lot of what we call heterogeneity changes. How tall is that cylinder? Okay, the cylinder that we're pushing down, very awesome use of geometric terms. A cylinder, this long metal tube here, is 2 meters long. And as you guys probably know, oh, I'm just paying attention here, sorry. Okay, we're vibrating down. It's not wanting to go down. We hit something hard.
We're gonna reclamp here.
So a meter is about 3 feet. So it's about 6 feet. 2 meters is a little over 6 feet. So it's about as tall as a very tall person, like our ROV pilot here. He's definitely 2 meters tall.
Scott's pretty tall too.
Scott, yeah.
I'm 2 meters tall.
I was talking about Scott, but Zach was taking the compliment for himself. Okay.
There's more slack.
Oh, wow. Okay, so Javier, would you like to introduce yourself? Javier is a local expert. He did his PhD in this area,
Just master's degree.
master's degree in this area, but
And I'm a local. I'm actually.
he's also a local.
Hi everyone, my name is Javier Cañete. I'm a geographer from University of Playa Ancha in Chile. I did my master's degree in the University of Auckland, who I'm currently representing here. And just because I'm in the ROV room at the moment, supporting the team with all the mapping and geophysics, I just came across some of the photographs that I took in 2013, which are quite identical to the material that we just came across at the seafloor. It really called my attention that the material looks quite identical, so I went back and reviewed my archives, and I'm actually looking at the computer now, seeing the Fan Delta in front of Chaitén shoreline.
On shore, after when you were standing on the shoreline, you took a picture of it,
Maybe you're just
Yeah.
right? And the
Looking at-
material.
And the material looks just like what we found in the surface 11 years ago.
Yeah.
So
Wow.
there is a lot of information to to correlate and understand from that data set. So I will pass it to the team and get back to baking now.
Woo.
Thanks.
Thanks, Javier. Yeah, you don't get more experience than that. He's gotten to walk out on the Delta. He's a local. He's from here, so it's really exciting to hear him talk about how similar these sediments are to the sediment that we saw on the Delta itself following the eruption.
It's a risk.
We'll do
It is
whatever
still
you
going
want.
down a little bit, isn't it?
So right now we're just trying to get the vibrocore to penetrate a similar amount of sediment as the last one.
Oh, I think this is a 2 meter course. I think it's done more now.
It's a longer tube.
Yeah.
Okay. Okay, Becky, so it seems like we're in a similar.
Oh wait, this is a
This is a longer tube.
Oh, haha. That tricked you out there. I was just testing if y'all were paying attention, okay? The first tube was 2 meters, so about 6 feet long. The second one was at 1.5. Sorry, 1.5. The second one, again, just checking if you're paying attention. The second one is 2 meters. It's hard being in the PIC seat. It's more pressure to know everything. But I'll take it.
Yeah.
Oh, yeah, totally. Ooh, all right. We have somebody from Italy who's studying hydrographic oceanography. Hello. Welcome. Yeah, so this area is very complex in terms of hydrography, and that's something we're having to contend with as we are sending this ROV to the seafloor. The currents have been quite finicky here. We got to operate right when it's in slack conditions in between changing currents. So we're trying to do this quickly, but of course we found some interesting material as much as we can before moving on to the next site. Board, Claudia is a master's student from Valparaiso, and she is the one that will be studying the physical oceanography here from the CTDs, conductivity, temperature, depth, and bring back up. It's a little bit faster than this operation with the ROV, but we learn a lot from it. We can get temperature, salinity, and then all kinds of information about, we have a fluorimeter, so we can get information about the chlorophyll A that's in the water column, turbidity, and we can learn a lot about the ocean from that. Yeah, I don't think we're gonna really get farther. But
Okay, cool stuff. Did you want to
Yeah.
vibrate on the way up, you said?
yes, vibrate before we come up. So come up just a little bit and then vibrate really hard.
Not all the way up though.
Okay,
Not
I'll
all the
do
way
a
up, just
little
come
bump.
up like maybe 10 centimeters.
Just on that extraction to sort of encourage. What do you think?
Yeah, but I think
Because what the only thing
you're saying vibrate
the only
on the
thing
way
that
up.
would prevent the core catcher closing.
Yeah,
Okay,
is that there's still
there's a couple centimeters
Yeah.
out.
yeah.
So as soon as it's closed out, the core catcher should close.
Mhm.
Right? So there's no point vibrating after that, right? You risk just.
Yeah, so we're getting stuff coming
Yeah.
out of the nozzle.
It made stuff come out the top when we did
Okay.
that, FYI.
What's that?
It made stuff come out of the top when we did that.
When you did
Oh
that?
yeah, it just sent a cloud of
Smoking out the top.
Okay. Seb was distracting
stuff. You
me.
don't want to do that.
Okay.
Okay, thank you for telling us. Yeah, so we're gonna stop vibrating,
Yeah.
Okay.
but we have an identical core to test.
So we did
We
a short
might-
vibration, and it lost a little bit at the top.
Yeah.
Yes.
Let's see.
The other one was 1.5.
I guess.
Yeah, I think we should have vibrated more
Yes.
just as a test because we have a core already here.
So they did vibrate briefly, right? That's why. It's
Yeah.
so-
Okay, we did it briefly. We can say we did a brief test.
Okay, opening clear.
So what we're trying to troubleshoot here is why our vibrocores aren't filled up to the point at which we've been sending them down into the sediment column. We send them, a 2 meter tube like this one that we just sent down almost all the way. We've been bringing them all the way up to the surface and looking at them on the ship.
Big job, Scott.
Did it go all the way in?
Almost. There was like maybe 30 or 40 centimeters at the top of the core, so close.
And a change in resistance, right?
it became much more resistant much sooner here, much shallower.
But still went in quite a long way.
Yeah, it went in. Yeah. The vibrocore is working because there's no way we could have done that with a simple push core. Yeah.
I hope,
Okay.
It's getting in there. It's just a matter of when we pull it up, bringing the sediment back with it. Amalia, you have an admirer.
What?
See that?
Oh, Fran.
Oh, again, your friend.
Again, it's my best. How is she not saying hi to me? It's unfair.
Okay, so we have two students in the room from Universidad de Chile in Santiago, Amalia and Mane. Amalia is finishing up her undergrad there, and Mane has just finished her undergrad and is coming to the University of Alabama for her PhD. Come on, you need to say, what do you need to say? I just said University of Alabama.
Roll Tide.
Woo! Roll Tide.
can
That's
you
our
just explain that?
motto.
to me?
We
Roll tide.
Roll
Am I
Tide.
hearing that right?
You have to say it with it. Can I say
So you're gonna
something?
go on the floor?
Yes, and Amalia is going to say
No,
something
I'm just
briefly.
trying to say hi.
Hola, Francisca y Natalie, las quiero mucho.
It's like the tide.
You see that?
Yeah, I see that. Awesome. Oh, yay.
We also call the Crimson Tide.
All right. And we made T-shirts that the Evolutionary Studies Club, Mane, we made T-shirts that say the real Crimson Tide. And then we have Karenia brevis, which is a dinoflagellate that makes the red tides. And yeah, the HABs, harmful algal blooms.
I want one of those.
I have one just for you that I saved for you. I'm serious. I almost brought it on the cruise, but I didn't have room. But yes, I have one.
Thank you, Becky.
Okay, we're focusing on putting this vibrocore back. Yeah, we have been distracting a little. What did you say? Oh, yeah.
Yeah, rolling tide is kind of messing up.
Rolling Tide Pod Challenge. Be quiet so Zach can get this in just the right spot so we can all. Ooh, wow. Now we can clap, or are we gonna wait till it's locked?
Okay.
Let's wait. Let's give him the focus to lock it.
Whatever does the maximum jinx.
Pop it and lock it. We don't want to jinx any of these cores. There we go. I'm gonna turn that little lever there to lock it in place. No more Tide Pod eating. All right. Woo! Great job, guys.
So
Okay.
you want a ski bag of the white stuff?
Hold on 1 second. Are we going to do another vibrocore without the valve?
Oh, you really wanting to experiment? Could we, if our risk is going to short time, could we get the scoop bag with the...
Okay, so get the scoop bag. We'll go to another site and then we'll try.
Okay, yeah.
Yeah? Okay.
I think we'd like that organic.
Yes, we want the white stuff with, yes, especially with the sticks, that woody debris there. That's going to be really, really good for us to have. And again, that's a great indicator of river influence here. That it's from the just to the east of us. Delta.
So it's interesting, a long way north of the outflow.
Seb's done for the day. He doesn't want to talk into a microphone. Yeah.
We're quite a long way north of the
Yeah.
outflow, right? And yet this
Yeah.
is where we've seen the strongest evidence
Yeah.
of recent debris,
Yeah.
delta debris,
Yeah.
the organic material, and a lot of pumice.
Yeah. Yeah, and so earlier today we were talking about where the sediment might be collecting on the seafloor, and Seb had immediately said it looks like it's being directed north. There's a whole debate about it, but I think he gets to say I told you so now. Yeah, he's looking very smug. too easy to draw. Too easy. Too early. Too early and too easy to draw conclusions here about that. But we're definitely seeing some finer grained sediment. Still pretty sandy, but not as coarse as what we saw earlier today in our other ROV sites that were south of here along the Rayas Delta front, or just offshore of it. Yeah, so there's a lot of really interesting features on the seabed here that we can see. We can image from the ship itself using geophysics, using acoustic sounding that bounces down to the seafloor and comes back up. We can see the shape of the seafloor, and we can even image into the seafloor to see the layering of the deposits within this area. And so we've seen a lot of cool stuff. We've seen some what look like large dunes on the seafloor just offshore of the delta, maybe making up the most distal or farthest towards the ocean part of the delta. Make sure we get the white stuff there. Yeah. I want to just focus in on that. Yes. No, the white stuff. We want the pumice.
Yeah.
I mean, we assume that it's like basically modern and yeah.
2008.
Could be 2008.
So these the river channel walls after the Chai-10 flows have been through were really undercut.
Yep.
So when I was in the river valley, like months after the eruption, and the walls were really clean, exposing really fresh geology, and all the vegetation soil was hanging over at the top.
Yeah.
And all these trees just toppling.
Yeah.
So it was the erosion of the banks that undercut the forest. You got huge volumes of trees sort of falling into the river system, as well, of course, as all the trees that have been directly broken by the pyroclastic currents.
Yeah. Producing what we call large woody debris.
Large woody debris.
Yeah. The banks of a river channel, you're expanding that river channel basically overnight, like that, then you're highly likely to just undercut the vegetation on either sides of the channel. And that's exactly what happened. So there's huge tree trunks, if you look in the satellite images, just sitting basically on the sides of the delta here.
Quite a good directional indicator.
Yeah. Yeah. So Dr. Watt is also saying that these trees are, they're elongate, right? And they're going to float a little bit, right, with a movement of the water and be organized by the direction of that water flow. So they can give us an orientation of the water flow. All right, we're picking up the sediment as best we can. Getting some woody debris in there. Ooh, did we get it? Almost. Yeah, that's definitely from a tree. Yeah.
Is that a stick?
That's a stick.
Is it?
Yeah, you kind of see, yeah, you can kind of see where it would attach to the rest of the tree, like a branch.
Becky, the other thing that strikes me is there's not much living here.
Yeah.
Compared to the lack of biology is really distinctive compared
Yeah.
to the sites, right? And
That's true.
a really interesting observation, right, in terms of the impact
Yeah.
of this part of the active delta
Yeah.
on biology.
Yeah, if you have a lot of sedimentation in an area, you're going to be
At our other sites, we've seen
Uh,
bivalves,
yeah,
blowfish.
yeah, echinoderms sitting on the surface.
What about our forams? Do we have higher sedimentation rates?
If we have higher sedimentation rates, even in this setting though, okay, so if you have higher sedimentation rates, sometimes you preserve forams better. There are forams that like those conditions, but here I think because the substrate is so sandy, I'm not sure that we'll have very many of them. It's kind of unlikely that we'll have very many of them, but we'll have to look.
Not even arenaceous forams?
Potentially arenaceous, but rates, really high sedimentation rates, you're going to cover them up.
And it strikes me that the pumice is really thick.
Yeah, here it's really focused flow, maybe collected here.
So when we're digging down, we're not getting into black sediment.
Interesting, not even
Yeah.
arenaceous forms.
Okay, so thank you. I was getting discussion at the same time. We're such nerds. Don't you love it? My kids, I know, love it. Not all my kids, but yeah. So foraminifera are single-celled, amazing little protists that build shells. They can either build shells from the material around them and glue them together. There's some are really neurotic about the size of the material they use. And then there are also forams that can precipitate their shells with calcium carbonate, just like a clam, right? And so, ooh, wow, that is super full. I'm very happy, guys. It's a good bag. Full bag. I feel like the guy, running away with the bag full of money, like the robber. Full bags of money. That's what I like to hear. Full bags. But yeah, foraminifera are very sensitive to changing conditions of water temperature, water salinity, the different critters living here, the substrate. So that's why Mane was asking about it. And she's going to be looking at forams from these cores for her PhD dissertation. Wow, there's a lot of pumice in there. Okay. Woo! Full scoop. Yeah, let's try to pick up the stick with the arm. Is that okay? Can we try it?
Or is that thing right underneath? Right underneath. That thing right there?
Okay, so I don't think you guys can see from your view, but we have another camera looking down onto the seafloor, and we are. This is so cool. It's just like the claw game, in arcades. Yeah.
Oh, wow.
Ooh, we got super diverse. The Valdivian forests of southern Chile are just gorgeous and very important ecosystem, ecological hotspot here. Okay, so this is. Yeah, it'll probably stay with us. Depends on the currents, maybe, but this is cool. I'm excited about this stick.
Okay, so suggest those other sticks we got back here.
Yeah. This is more like a log. I don't know. This is like a branch. Yeah. Wow. Awesome. We're just doing yard work here. We're just picking up the sticks. Getting ready to mow.
Right.
Cool. So, plan. We're going to fly to another site and try to get another core. Checking on the currents first.
2.9, is that?
What is it? So from the ship we can actually see the current velocity through acoustically sounding the water. Yeah. It was the Kohue?
Surface has increased.
Kohue? Or una lengua?
So I think if that goes to about 1.2, we got a 14 fish.
So I think we basically caught one of these.
Yeah. What if we move over?
So if we move in, then it's just
due east.
thicker like this. Or
We
if
go
we
due.
move this way,
I think we
get
should
out
move
of it.
in.
Do you want to go in?
Yeah. Let's go due east and try
I
to
think it would just be more of the same, but yeah, why not?
Okay. But see, this is more like in a goalie channel.
It doesn't like
if we
do you
go
want to go onto the
there-
crate? Oh, you want to go onto one? Like just a few meters.
Yes.
Yeah, it's fine.
You think?
Let's try.
Okay.
So you're saying that we're through the change on the surface?
So what I mean by the last forest of Antarctica is before it became glaciated, we can actually see the pollen that's deposited on the seafloor.
He's a friend of mine from University of Chile.
Oh.
He's a paleo-magician. He's one of my
Paleo-magician?
Paleo-magnetism. We
Oh,
call ourselves
yeah.
paleo-magicians.
Paleomagnetism is very useful for telling stories about the past from geological records, from sediment records. So we can look in those pages of the books of the sediment books that just called in to Dr. Fernandez from University of Chile. All right, so now we're flying the ROV to a different site. We're going due east, correct?
South.
We're going south. Can we go a little bit more east?
East? Okay.
Yes, I would like to go east.
Go east person.
I thought it would go west.
Depends on where you are.
I guess it depends on what. If you go far enough, though, you'll end up going east, right? Going west.
I was a ski bum once in Washington State, and from Bellingham, you go east to get to the mountain, and so they're so.
That's
depends on
cool.
where you are, yeah.
That's cool.
Camera, vehicle, everything.
Yeah. All right.
So if you're travelling ahead, those ripples are crosses.
Mm-hmm.
Yeah. The alignment.
Oh wow, what's that surface over there to the?
Yeah.
That would be to the north.
To the north.
Oh wow. Okay, so this is one of these larger bed forms, almost like a dune. We're calling them dunes, but it's not quite the right terminology. And then we have these ripple sets on the backs of the dunes. It's kind of interesting here. Can you make an event for this? You come back and look at it? Oh.
So do you want to move along
Yeah,
the crest of that?
let's move along the crest of this and let's keep going roughly east.
Okay, we'll follow it.
Yeah.
Okay,
So
yeah,
the alignment
yep.
of the ripples is east-west. Yeah.
Yes.
Cool.
We might need to do a ship move.
Do a what?
Ship move.
Oh, okay.
Sure.
We're going a little too far.
How far do you want to just keep going on this?
Yes, I would like to go at least like 20 more meters. Is that okay?
I think some nice features, nice
Yeah.
sedimentary structures.
Bridge, RV, got a new move for you.
So we gotta bring the ship towards us.
Sort of arcuate.
Our leash is getting a little tight here.
Ooh, which one? They just split on the left? This one?
Yeah, let's do the one on the left. To the north.
Is there a split?
Yeah, look, there's, bifurcated.
Yeah. Cool.
Yeah, there's also woody debris here.
What do you
Yeah.
agree?
So I think the sample that we took is nicely representative of this species, of this sediment type here. My dendrochronologist friend just texted me that he is very much excited about the woody debris that we're finding. Yeah, there's a pretty active dendro community here in South America. They've got all the chronologies pretty well figured out, which is something that Mane is learning about in her class from my friend right now. Yeah. Yeah, so the leaves that we saw in the cores over the last, well,
So if you were potentially have more time, I would actually suggest to go west.
to go west to go
To
out.
the margin of this.
Okay.
And see if we can see the seafloor.
Okay.
What do you think? So, did you want to
Yeah,
take
we
a
can do
call?
that.
Do you
We
want
can
to
do
take a
that.
call here, maybe?
I would, yeah.
I want to-
You know, you're not going to see it. It's going to take a long time for that community to come back.
What's interesting
Yeah.
is we were on a sort of tube-like body earlier,
Yeah.
coming in this course set,
Yeah.
but there was still quite a
So
lot
that's your only
Mhm.
view.
there.
Mhm.
And certainly when we were onto the pebbly units,
Yes.
there were loads of stuff there.
Yes.
So,
And so those pebbly units, it was almost like a pavement that had been there for a while. Yeah.
Here, we're seeing here,
Yeah.
remains of impact.
Yeah, here we're seeing a lot more mobile sediment, loose sediment, finer sediment that may have been valve on the top. So we're gonna test if that helps improve our core recovery.
I suppose it'd be useful to know if the band beam is a relatively working successful method that we can use in this sort of context. That'd be useful.
Okay, and Javier's back in the room, very excited again about the debris. He never left. Okay, he was just in the back of the room. Yeah, all right, we're gonna core this. See what we can get back up to the surface. Yeah, there's no doubt in my mind when you pick up the currents again, the woody debris and the pumice is gonna move.
I'm gonna wash that a little bit and re-grab. Sure.
So I don't know that this is necessarily so we need to think about depositional history here.
I think what'll be interesting in the core, it really strikes me this black sand really on the top.
Mhm.
And it's
Yeah, it could be.
stuff carried in just from floods.
Yeah, or reworking.
Seasonal material.
Yeah.
Because also we've been seeing, under the microscope it's very mixed. The black sand has got, mafic crystals and lithic sources, things that would not be from content.
Bottom.
And here it's striking us on top. We'll be able to see that in the core. I might be totally wrong with that about that. That's where the core will tell us, give us some understanding of the stratigraphy.
Yeah, hopefully we can punch this into the lower units and actually bring them back up to the surface. Get a nice long core.
Because the students could be quite a thick deposit here.
Mm-hmm. Yeah. Which
Length
How long
of
is
tube,
the-
how long is this tube?
this one should be 2 meters.
2 meters?
Let me check.
Reaching down?
Scott,
Yes.
is this a 2 meter core? Is this a
Yes.
Scott length core?
It is a Scott core. Scott
Okay.
length.
Let's go.
One
Yeah,
Scott
we're gonna
unit.
measure these in Scott units. This is a 1
That's a
Scott.
good term. Yeah.
Yep.
I agree.
1 Scott core.
Is that the same as a clod?
A clog.
Maybe.
Yeah.
Yeah, I think it's the same as a clod. Clod is also about 2 meters tall.
Amigo Largo?
What's that?
It's currently in about half a Scott, I'd say.
Yeah, half a Scott.
Yeah.
I think it's about a Chris now.
Oh, we're really not seeing much biology here. There's a little swimming shrimp. Did you get that, John? Okay. Thumbs up on. Yeah. This is great. My only fear right now is that we go west and we find a better site and we don't have an empty barrel.
Well,
It's my greatest fear right now,
well, I'll
but
tell
we
you
could
what,
always
maybe
come
we go
back.
west and we understand the sea floor,
Yeah,
because
yeah. Okay, we're shaking the core barrel.
Try doing a bunch of slack, maybe you can pull it out in the front, you know what I mean? And then come up and put. I know. Well, a lot of people try, I guess. Put that bolt or something.
Yeah. Garden hose theory. Drag a garden hose through the yard and catch on everything it possibly can. You tie a grappling hook to a rope,
Yeah.
weave it through the forest, tie it the other end to yourself, jump off a cliff. You will die. That grappling hook will not catch on. But the garden hose?
The garden hose
They
will.
catch on every single possible thing.
I can see that. Okay, some of the other things I'm noticing here is just some of the water conditions. It looks like we're somewhat fresh, 33 in the salinity, but we're 90% oxygen here. There's really no reason to not have organisms here other than having a seafloor that's been recently covered.
It's not so recent though.
Yeah, I mean, it could, yeah. Depends on how long. Pull up or just shake it and then pull up. Pull up or just shake it and then pull up.
I don't see the value in shaking.
You
It sit on its way.
free the line.
Okay.
Surely the cord might
Can you
shake.
free
Might
the line?
open.
Closed by that point.
Okay.
Flick it off.
You want it to close early on the extraction.
Yeah.
right?
Yeah.
If it hasn't closed, you're still losing stuff.
If possible.
Yeah.
So you kind of want to.
All right, so we'll shake it a little bit in place
Okay.
and then pull up.
Okay. We're just the line got caught off.
I see that. I see that.
You think like shaking it for the first 10 centimeters or so.
Yeah, that's
So
what I was thinking.
You're freeing it.
Yeah.
You're freeing it from what it's gone into and
Yeah.
letting it close.
Yeah,
Yeah.
that's what I was suggesting earlier. Yeah, I think it makes sense. So shake it as you pull up about 10 centimeters. Stop and then pull it the rest of the way. Okay. Sounds good.
Okay. Once you're done. Perfect.
There we go.
Okay.
Got the garden hose unstuck.
Okay. So we want to shake now.
I just mean the rope.
Is that the deal?
Yes, we're going to shake and pull up only 10 centimeters.
Okay.
Stop, and then we'll pull up the rest of the way.
Okay.
It may be slightly.
Okay. 10 centimeters.
that-
It may be
Looking
slightly
at
different.
our
Yeah.
graduation there, ready to shake.
I mean, I guess if the first one we collected again is really short, then that's
Yeah.
Do we know when you're shaking?
Yeah.
We know we have a rough idea of how far we've gone in.
Yes. Yeah, most of them have gone in all the way. Almost all the
Like we
way.
should be recovering that same way.
Okay.
Mhm.
Recovering core.
Done so many vibrocores on land. It's just very confusing to not have a full barrel when you looks like you filled it up. You know.
It's really stiff coming out there. I gotta go down.
Did you real quick?
Okay. This is steady coming out on the surface.
So you're getting resistance on the way up.
Okay.
Okay.
Yeah, this is steady resistance coming out. Usually it's faster than that.
Okay. Okay.
Resistance in the way up.
Mhm. Mark that in the log. Awesome. We have the best students on this cruise. I don't know if anybody's talked about that, but we have the very best students. They're always thinking ahead, anticipating what's going to happen next.
And they're giving me chocolate.
They're giving us all chocolate. I just ate a piece.
And
It was,
guaguitas.
And huevitas, which
Yeah.
is kind of like a marshmallowy, but it's sweeter, marshmallowy type candy. Flavor's really good. With flavor. Yeah. Very classic Chilean candy. And it means little babies. Huevitas.
I didn't know that.
Yeah, they're like little, every time they say, what are you saying? Huawitas. Okay, and every time they say that, they act like they're cradling a baby. Do the arm motion there. But yes, they give us candy. They anticipate what's going to happen next, what's needed. They take careful notes. Been doing a lot of training, a lot of student training on this particular expedition. We have how many students?
We have, I don't know,
We should tally them.
I think we
I
have
have a list.
10, more than 10.
We have more than 10 students. We have 4 postdocs, all very passionate about their science and I think even more importantly about working together. So it's been very collaborative. The majority of our students are from Chile, but we also have students from the UK in Birmingham. We have students from the University of Alabama.
Roll tide.
Good job. You need to make that more of a reflex.
Yeah.
You're working on it.
I will.
Working on it. Okay.
Wait, us? Was that?
Oh, I've trained the the Schmidt Ocean Institute's crew here. Everybody's gonna be saying it by the end. Okay.
Yeah, all our students are from Chile, except for Paris, right?
Yeah.
It's like
Yeah.
right?
And then University of Alabama. So Roll Tide. Good job, Seb. That's minus points, Mane.
Roll tight.
Oh, good job. Good job, Javier. Also, we're also a very rapidly growing university for research. Since I got there, we got our R1 status. We've got a lot of cool research and awesome students
What does
researching there.
status mean?
It means we're like top in the nation. Yeah.
Not. I feel it's a very American thing.
Yeah.
It's not like.
But you have like rugby and lacrosse and.
Yeah, but not linked to universities or like. So it's
yeah,
not,
yeah.
It's just linked to what you think. It's linked to
Yeah.
towns and
So
locations.
the towns. Okay.
University sport is not. Doesn't have the same sort of. I guess interest. Sort of, I guess interest. Sort of, generation the US, like a sort of top level. It's a
Yeah.
big deal, right?
Yeah.
If you're from.
All right. So now we're gonna let the ROV team focus a little bit.
We're coming off bottom here.
So
Coming up on, copy
we'll
that.
have to
Thank you,
discuss
sir.
whether we can use
Yeah.
so much roll tide.
Yeah. Roll Tide, but on a low current, please. Not so much.
to rain back here.
I grew up in Louisiana, so it's uncharacteristic of me.
So what would you say in Louisiana?
Let's see. It's like live purple, bleed gold, or something. I don't know what they say. The Tigers are crazy. But that's LSU. I'm talking about LSU.
Which one's your
But
natural?
I grew up in New Orleans, so I actually went to UNO, which is a privateers, bunch of pirates.
Which one's your natural enemy?
You mean like the natural enemy
Of the
of?
roll tide people. What's the resident enemy?
Oh, I would say it's War Eagle, the tiger, whatever, the Auburn tiger.
And what's their saying or whatever, so I can say it.
War Eagle. Don't say. Why did I just teach you that?
War Eagles, huh?
But yeah, in New Orleans we say "who dat." Just to come back to that, my first ever cruise went "who dat."
Who that Wode?
My first cruise was in 2009 with Rodrigo. We sailed together to Antarctica on a Swedish vessel called the Odin. And yeah, also Odin Southern Ocean. Only 2 years was it in the Southern Ocean there. But yeah, the Saints.
You could probably start making your way to the north if you can, Chris, 'cause that'll be.
I'm Scott.
Or Scott. That'll be. Sorry.
It's all right.
1.5, Chris.
Oh really? I can't see. Are we still alive? All right. Oh wow.
We love Chris. He's like our. Hey, bud.
So we're bringing the ROV to the surface because the currents are picking up, and we're trying to bring it up before they pick way up. So it's easier to get it back on the ship.
Yeah, so we will definitely do a move. If you guys are good with that.
Alright, so right now you're 4 floats on surface going to the stern, slightly away from the.
Okay. Are they in a safe spot or are they
They're
extreme?
fine. They're not in a great spot. They're not like in home and home.
Okay. Are you happy for me to pass you control?
No, so I don't have the
Oh.
thing, but I can tell you what to do. Keep coming in.
Okay. We will come up and keep coming in. We are at 110 already.
Alright. As soon as Joe hits the.
Yep.
I was shallower right back when I went back down.
Yeah, we can wait.
Yeah, you're fine.
Okay.
As long as we're not in danger. We'll wait.
Nope, you're actually fine. Let's
Sure.
just,
Should I
When are
enter
we
the
diving
circle of
again?
doom? Sorry.
Never mind. Are we?